So today the problem that I am going to discuss is from GATE Mathematics 2024, and the question is from linear algebra part. And in the question we have given a normal matrix with two statements. Statement 1 is if all the eigenvalues of A are real, then the normal matrix, that is A, is Hermitian. And the second statement is if all the eigenvalues of A have absolute value 1, then A is unitary. Now you have to find uh, which one is correct. The question is from MCQ section. So before solving the question, I'm writing some information that I'm going to use to solve the question. The information are information 1, a matrix A is normal if A and A star equals to A star A. Uh, Here A star is the conjugate transpose of A. Second, a matrix A is called Hermitian if A equals to A star. Third, a matrix A is unitary if A and A star equals to A star A, which equals to I. Which is identity matrix, that we all know. And fourth is important, which I'm going to use here, is spectral theorem. Spectral theorem. The theorem said if you have a matrix which is normal, and if and only if it is unitarily diagonalizable. And one more statement information I'm going to use is if A is normal, then there exists a unitary matrix U and a diagonal matrix D such that A equals to U D U star. So the diagonal entries of D are the eigenvalues of A. Of A. So how I'm gonna solve it? First, I'm gonna analyze the statement separately using the properties of normal, Hermitian, and unitary matrix. So let's analyze statement 1. That's it. If statement 1 is not this, statement 1 is if all the eigenvalues of A are real, then A is Hermitian. So now if all eigenvalues of A are real, then the diagonal matrix D is the spectral decomposition you know. If you guys don't know what is spectral decomposition, just the um, go through the concept from Google. You will know that this is very easy. That has the real entries. So if D has real entries, then you can write D equals to D star, and since A equals to U D U star, then now we can write A star equals U D U star, the whole star equals to, now I'm breaking U star, U D star, U star. So if D equals D star, then A star equals U D U star, which is again A. So we prove that A is Hermitian. A is what? Hermitian. So statement 1 is true. Now analyze statement 2. So the statement 2 says if all the eigenvalues of A have absolute value 1, then A is unitary. Let's check it if it is true or false. So if all eigenvalues of A have absolute value 1, then for each eigenvalues lambda I of A is also 1. This means, this implies lambda I and this will be 1, and the diagonal matrix, so the diagonal matrix D has entries lambda I. So D star D has entries lambda I bar and lambda I, which is again lambda I square, which is 1. Thus we can write D star D is now 1. And we already know A equals U D U star, then A star equals U D star U star. So now again compute A and A star, which is U D U star, U D star U star, and this is again U D this U D D star U star, which is again U I U star, which is U V U star, and which is I. Next compute A star A, which is U D star U star U D U star, and this is your U D star D U star, and this is your U I U star, which is U U star, which is 1, which is 1. So A is unitary. So statement 2 also true, right? we have uh, I've already proved that statement 2 is correct. So because that what the question asks, if A is unitary or not, and I already proved that A is unitary. So the correct answer is both 1 and 2 are true, which is option A. So that's it. Thanks for watching.